V8 engines. They're the stuff of muscle car legends and racing dreams. But not every V8 was built to shake the earth. Some of these mechanical masterpieces were engineering marvels of miniaturization. Today we're uncovering the 11 most remarkable compact V8 engines ever created. Starting at number 11, we have the groundbreaking Oldsmobile 215 V8 from 1961. At just 3.5 liters, this aluminum powerhouse revolutionized engine design. The entire engine weighed only 318 pounds, nearly 200 pounds lighter than comparable V8s of the era. Its aluminum construction was so advanced that initial production faced numerous challenges, including porosity issues in the casting process. Engineers solved this by developing new casting techniques that would later become industry standards. The engine featured a wedge-shaped combustion chamber design and 5 main bearings, which was advanced for its time. Production numbers reached over 750,000 units before the rights were sold to Rover. Factory testing revealed remarkable durability, with engines surviving 100-hour endurance runs at maximum power. The innovative cooling system incorporated precision drill passages that maintained cylinder head temperatures within a 2-degree tolerance, exceptional for the era. But if you think that's impressive, wait until you hear about our number 10 contender. Ford's 3.4-liter collaboration with Yamaha represents a perfect marriage of American muscle and Japanese precision. This transverse-mounted V8 was a technical triumph, featuring a unique 60-degree V-angle instead of the traditional 90 degrees. Each cylinder head contained dual overhead camshafts and 5 valves per cylinder, 3 intake and 2 exhaust. The innovative valve arrangement created a highly efficient combustion chamber design, achieving a remarkable volumetric efficiency of 95%. Development took over 4 years, with engineers conducting more than 10,000 hours of durability testing. The collaboration resulted in exotic features like titanium connecting rods and a lightweight aluminum block with cast iron cylinder liners. Each engine underwent a 27-point inspection process before installation, with critical tolerances measured to within 0.0002 inches. Speaking of engineering excellence, Jaguar's 3.2-liter AJV8 takes 9th place. This engine wasn't just about numbers. It introduced several innovations in manufacturing processes. The block used a unique casting method that created hollow sections for reduced weight while maintaining structural rigidity. Variable valve timing and sequential fuel injection helped deliver 237 horsepower while meeting strict European emissions standards. The engine management system could adjust timing and fueling across 3,000 parameters, ensuring optimal performance in all conditions. Each engine underwent a 12-hour hot testing procedure before installation. The manufacturing facility in Wales employed laser-guided assembly robots for precise bearing and piston fitting. Development costs exceeded 100 million pounds, but the resulting engine set new standards for refinement and efficiency. Here's where things get really interesting. The number 8 position showcases Daimler's innovative 2.5-liter V8 from 1959. This compact power plant was revolutionary for its time, featuring hemispherical combustion chambers when most manufacturers were still using wedge-shaped designs. The aluminum cylinder heads and iron block combination helped balance weight distribution and thermal properties. Making 140 horsepower might sound modest today, but this engine could rev to 6,800 RPM, exceptional for the late 1950s. The engine block incorporated unique cooling passages that reduced thermal stress, while the valve train used hollow push rods to reduce reciprocating mass. In competition form, some units achieved over 170 horsepower through careful tuning and higher compression ratios. Factory records show that each engine required 28 hours of assembly time, with critical components hand-selected for optimal fit. If you're fascinated by these engineering marvels, hit subscribe to explore more automotive history with us. You won't believe what sits at number 7. Tatra's air-cooled 2.5-liter V8 represents Czech engineering at its finest. This unique engine eliminated the entire cooling system, saving significant weight and complexity. Each cylinder featured 12 cooling fins, precisely engineered to maintain optimal operating temperatures even in extreme conditions. The cooling fan system used a sophisticated thermal control mechanism that adjusted fan speed based on engine temperature. Each cylinder had independent cooling channels, and the oil system included an auxiliary oil cooler. Testing included running engines continuously for 100 hours at maximum power, a brutal endurance test that few engines of the era could survive. The innovative magnesium alloy cooling shrouds reduced weight while improving heat dissipation by 15% compared to aluminum alternatives. But hold on to your hats, because number 6 will surprise you. Ford's Thrifty 60 2.2-liter flathead V8 demonstrated that efficiency could coexist with the V8 configuration. Built from 1937 to 1940, this engine featured a smaller bore and shorter stroke than its larger siblings. The flathead design, while simple, provided excellent low-end torque characteristics. Ford engineered special fuel-efficient carburation systems and a unique cam profile that prioritized economy over outright power. The block casting incorporated water jackets designed to prevent hot spots, while the crankshaft featured larger bearing surfaces for improved durability. Period testing showed fuel economy reaching 30 mpg, remarkable for a V8 of any size in the late 1930s. Factory records indicate that production costs were actually higher than the larger flathead V8s due to the precision required in manufacturing. And just when you thought engines couldn't get more exotic, here's number 5. Fiat's innovative 2-liter V8 showcased Italian engineering prowess from 1952. This engine featured advanced design elements like forged steel crankshafts and aluminum pistons with steel struts for thermal control. Twin Weber carburetors fed fuel through carefully designed intake runners, helping produce up to 125 horsepower at 6,000 RPM. The valve train incorporated sodium-filled exhaust valves and dual valve springs to prevent valve float at high RPM. The engine's compact dimensions resulted from an innovative staggered cylinder arrangement that reduced overall length by 3.2 inches compared to conventional V8 designs. Now we're entering the realm of pure engineering artistry with number 4. Alfa Romeo's 2-liter V8 demonstrates race technology adapted for road use. This engine featured double overhead camshafts, mechanical fuel injection, and dry sump lubrication, technologies typically reserved for pure racing engines. The aluminum construction included silicon carbide cylinder liners for reduced friction and improved heat dissipation. The crankshaft was machined from a solid billet of chrome molybdenum steel and underwent cryogenic treatment for increased strength. Each connecting rod was weight matched to within 0.1 grams, while the pistons used a complex thermal barrier coating developed for Formula One engines. Development testing included over 1,000 hours of dynamometer running at full load, with oil samples analyzed every 10 hours for metal content. Just missing the top spot at number 3, Lamborghini's 2-liter V8 showcases Italian tax law ingenuity. Engineers maintained performance standards by employing 4 Weber 40 DCNF carburetors and an 11.5-to-1 compression ratio. The engine featured sodium-filled exhaust valves and forged pistons to handle its 7,500 RPM redline. Each cylinder head underwent 5-axis CNC machining to ensure precise combustion chamber geometry. The engine block incorporated sintered metal cylinder liners with a crosshatch pattern that reduced oil consumption by 40% compared to conventional designs. Laboratory testing included over 500 hours of full load operation before production approval. Each engine required 35 hours of assembly time, with components matched to within microscopic tolerances. The runner-up position belongs to Ferrari's 2-liter V8 from the Dyno 208 GT4. This engine demonstrated Ferrari's mastery of small displacement performance. The flat plane crankshaft design reduced rotating mass and allowed higher RPM operation. 4 Weber 40 DCNF carburetors and 9.0-to-1 compression helped produce 168 horsepower at 7,700 RPM. The engine's construction featured Nikasil-lined cylinders and forged internals, ensuring reliability despite its high-performance nature. Each connecting rod underwent magnetic particle inspection and was balanced to within 0.5 grams. The camshafts were ground from hardened steel billets and featured a proprietary profile that maximized mid-range torque while maintaining high RPM breathing efficiency. Development included over 2,000 hours of test bench running and 100,000 kilometers of road testing. Finally, the incredible Souer V8, introduced at the Paris Motor Show in 1919, stands as a bold testament to early automotive innovation. Widely regarded as one of the smallest V8s ever built, this experimental engine pushed the boundaries of compact V8 engineering. Boasting a displacement of just 1,408 cc, it featured advanced overhead valves and a lightweight design tailored for a sleek 2-seat torpedo body. While precise details about its performance remain elusive, its ambitious construction reflected meticulous craftsmanship with individually cast cylinders and a focus on modern design principles. Although production of this groundbreaking model never progressed, the Souer V8 remains a remarkable example of post-war ingenuity, cementing its place in automotive history.